On Friday, we were in the process of completing this problem when we left.
It was 3 plus 2x over x.
The previous problems were a little bit more simple, simplifying complex fractions. But for those of you who were out, this is an important skill in a lot of when we're dealing with rational functions, when we're dealing with trig identities, we're going to use this skill. When you are in calculus and you're doing the long version of finding the derivatives of rational functions, you'll use this process. Okay, simplifying complex fractions is an important skill, not in and of itself, but we'll use it for other things. Okay, because it's a useful skill, they kind of make a rule in mathematics that a simplified expression cannot have a complex fraction. In other words, we can't have a fraction that has a fraction in it. We've got to do something so that we just have one fractional expression, and we showed on Friday that if we multiply the numerator and denominator of this fraction by a common denominator, then all the fractions will go away. We'll do the same thing when we're solving equations. If we multiply through an equation by a common denominator for all of the fractions in the equation, the fractions disappear. Okay, so the common denominator that we multiply this equation by was 3x over 3x. And then when you distribute this expression, 1 over x times 3x, the x's cancel and we're just left with 3 plus, that's this plus sign, when you multiply 2 over 3 by 3x, the 3's cancel and we're just left with 2 times x, which is 2x. Right? And then in the denominator, likewise, if you multiply 1/3 by 3x, the 3's cancel, and you're just left with 1 times x, which is x. And then when we multiply 2 over x by 3x, the x's will cancel, and we're left with 2 times 3, which is 6. All right, and we have to determine if there's anything that can be simplified once we're done with that process. Nothing can be simplified in 3 plus 2x over x plus 6. We might be tempted to cancel those x's. You might be tempted to cancel the 3 with the 6, but you can't do that because they're terms, and you cannot cancel terms or parts of terms, only factors. Okay, so that is the final answer that we'll be dealing with in this expression. Okay, so all we're doing is manipulating the expression to get rid of the complex fraction. Okay, now let's move on to something that's a little bit more complicated than this one. All right, so let's have a look at our next example. Yeah, and this one's a little bit more complicated. Okay, just a little bit. Okay, now I don't want you to get overwhelmed by this. I just want you to evaluate what it is that we're looking at, right? And a lot of students I have found when they get to problems like this, they have even a hard time kind of separating things out. So let's look at the pieces of this expression. This fraction bar here, draw a better picture. This fraction bar separates the numerator from the denominator, right? So because there's a fraction bar there, we're looking at one term. There's this one great big term that we're looking at, this thing right here. Within that term, we have a numerator and denominator. The numerator has 2 terms of its own, right? We have a term here. We have a term here. They're being subtracted. That's important. And in the bottom, we have a term there and a term there, and they're being added. Okay, so that's what we're looking at. We're looking at 4 terms within a bigger term that's all held together by this fraction bar. Now, because there's a fraction within a fraction, we're going to eliminate the fractions by multiplying the top and the bottom by a common denominator. All right, so let's just follow the process that we did in the last example. What is a common denominator that we would use for this problem? What is a common denominator of all the denominators?
X plus 1, x minus 1.
I need to multiply top and bottom by x plus 1 and x minus 1. Okay, do I need 2x plus 1s? No, it's a trick question. Okay, I just need 1x plus 1, even though there's 2x plus 1s here. I just need 1x plus 1. It'll get rid of both of those, right? Okay, so I'm going to multiply top and bottom by x plus 1, x minus 1. You can put it in fraction form like that, or you can just leave it as x plus 1, x minus 1, however you'd like to do it. Because what we're ultimately multiplying by here is something over itself, which equals 1. Now remember, what are we allowed to do with terms? What are we allowed to do with terms in mathematics? We're allowed to do two things. What are those two things? We can multiply it by 1, or we can add 0. That's the only two things we're allowed to do to a term. So I'm multiplying my original term by x plus 1, x minus 1 over itself. So what I'm really multiplying by here is 1. And we're allowed to multiply by 1. Okay? Now, when you multiply, we're going to do this term times this term. What's going to cancel when I multiply those two terms? What cancels when I multiply this first term by this thing here? The x minus 1s will cancel, right? So I'll be left multiplying x plus 1 times x plus 1, which is x squared plus 2x plus 1. Okay? Just to make sure you're clear with that, when I multiply this term by this, the x minus 1s cancel, and I'm left multiplying x plus 1 times x plus 1, which is x squared plus 1x plus 1x plus 1. That's x squared plus 2x plus 1. Okay? Good? So that term is fixed, so to speak, because it's no longer a fraction. Now I'm going to multiply this expression, that term by that expression, and what's going to cancel when we multiply those two things? The x plus 1's cancel, and I'm left with x minus 1 times x minus 1. But we got to be really, really careful. This negative sign is extremely important, right? It comes down. And when you multiply x minus 1 times x minus 1, we get x squared minus 2x plus 1. Okay, just to be clear, let's make sure you see this. I'm multiplying this term by this. The x plus 1's cancel, and I'm left with x minus 1 times x minus 1, which is x squared minus x plus 1. That's x squared minus 2x plus 1. And that negative sign comes down right there, because the negative sign in front of a fraction has to distribute through the entire fraction. Okay? All right, so that's what we're going to have in our numerator. Now, we've accomplished our mission here, which was just to get rid of the fractions. We're finished with the top. Now we've got to do the bottom. All right, so I'm going to multiply x, this term, times this. What cancels when you multiply those two things? The x plus 1's cancel, and we're left with another x minus 1 times x minus 1, which is x squared minus 2x plus 1. Okay? Just to be clear, x minus 1, then we multiply this by this. The x plus 1's cancel, and I'm left with x minus 1 times x minus 1 again. All right? Now, one more. Have to multiply this by this. What cancels when I multiply those two things? X minus 1 will cancel, and I'm left with x plus 2 times x plus 1, which is, don't forget the sign here, this plus comes down, x squared plus 3x plus 2. So when you multiply this by this, the x minus 1's cancel, and I'm left with x plus 2 times x plus 1. And when you multiply x plus 2 times x plus 1, you get x squared plus 3x plus 2. Good? Now we just got to simplify denominators, numerator, and see what we come up with. Upstairs we get x squared minus x squared. That's going to be 0x squared, right? 2x plus 2x will give us 4x. And then 1 minus 1 is 0. So our numerator is just 4x. In the denominator, we're going to have 2x squared plus x plus 3. And that won't factor, right? We don't have to worry about anything simplifying or canceling here because 2x squared plus x plus 3. 2 times 3 would give us 6, and there are no factors of 6 that have to be positive 1. So really the only thing that can't cancel anyway would be a GCF between these two terms, and we're not going to have that, so we can't simplify it any further. And that means that this is our final answer. Okay, now that's about as difficult a complex fraction problem as you would have to work in this class. Okay, or even in trig, you're not going to have to deal with anything that's more complicated than that. All right, any questions? Okay, let's look at just a couple examples. We've got a short lesson today because we started it on Friday. So we've got 3 over x minus 4 over 1 over x minus 4 plus 3 over x plus 1. Now what we're working with here is a complex fraction. We can't have fractions within a fraction. It's not an acceptable form for an expression. So I've got to get rid of the complex fractions. I'm going to do that by multiplying it by some form of 1. In this case, that 1 needs to represent the common denominator of all denominators divided by itself. So what would the common denominator of all the denominators be? What do I need? I need an x minus 4 and an x plus 1, right? So I'm going to multiply top and bottom by x minus 4, x plus 1. If you want to put that over 1, you are welcome to. It doesn't matter if it's there or not. It helps some students see what numerator and denominator is and how we're multiplying these things. Now the top's pretty simple, right? When we multiply the top here, what cancels? The x minus 4's cancel, and we're just left multiplying 3 times x plus 1, which is, I tell you what, let's leave it as 3 times x plus 1 for now. Because it's just one thing. And you never know, you might have a factor of x plus 1 in the denominator a little bit later, or something that's divisible by 3 that could cancel out. So if you leave it in factored form at this stage, it's okay. All right, now in the bottom, when we multiply 1 over x minus 4 times this, what cancels? X minus 4 cancels again, and we're left with 1 times x plus 1, which is just x plus 1, right? Because when we multiply this by this, the x minus 4's cancel, and 1 times x plus 1 is x plus 1. So that's where those things came from. So you can see how multiplying by the common denominator just eliminates all the denominators. That's what our goal is, right? So, and then the last thing I need to do is multiply this term by this. And when I do that, what cancels? X plus 1's will cancel. And I'm left with plus 3 times x minus 4. That's going to be positive 3x minus 12. So I'll have 3 times x plus 1 over 4x minus 11. All right. Now, is there anything that we could do to simplify that or cancel it? No common factors, right? So I'm okay with you leaving it as 3 times x plus 1. Technically, that's not simplified because we can distribute that 3, and we would get 3x plus 3 over 4x minus 11. When we're dealing with rational expressions, We're always going to leave denominators factored, but as a general rule, we will kind of multiply the numerators together to simplify the expression. I'm not going to count it wrong if you left your answer like that. That's correct. Okay? Any questions? Okay, let's try this one on your own then. See how you do on this one. Okay, what do we get here? What'd you get, Noah?
2x over 5x minus 1.
2x over 5x minus 1. I believe that is correct. Okay. All right. So, and the process here. Let's run through it real quickly. Most of you got this right, but let's make sure that everybody gets it. X minus 1 times x. Now, as I was walking around, I noticed some of you do a lot of this process mentally. Bryce, be careful. This is a tough skill to do all here, and you did a really good job of pulling it off, almost. It was like the Peyton Manning commercial. Y'all seen that one where he's in a recording studio with Brad Paisley. He's like nearly perfect. It's almost nearly there, you know. That's hilarious. As if Peyton Manning could give him advice about music. All right. When you multiply that, you get the x minus 1's canceling, right? And that leaves us with 2 times x, which is twice x, right? In the bottom, when we multiply this by that, the x minus 1's cancel, and I'm just left with 4 times x, which is 4x. When you multiply this by this, the x's cancel, and we're left with plus, always note the sign, plus x minus 1. Now, the only thing we can do there is combine like terms in the denominator, and that gives us 2x over 5x minus 1. That is our final answer. Okay? Pretty easy skill. Okay, now I want to point out something to you in this problem that's going to kind of be relevant to some of the homework problems on this in this section. I have 2 factors of x minus 1 here. But I only need to multiply by one of those factors of x minus 1. And that was kind of a common point of confusion. Some of the homework problems look a little different from this, stretching you to know the process. We only need one factor of x minus 1 to get rid of x minus 1. Now, if I had x minus 1 squared in my problem, if I had anywhere an x minus 1 squared, then I would need to use 2 factors of x minus 1 to get rid of that. Okay, but as long as you just have one factor of x minus 1 anywhere, you only need one to eliminate. Okay, now your homework is page 85. Now, we have got 20 minutes. We're going to work it. We're going to work. I'm not going to visit this 20 minutes away. So, page 85, there's 6 problems. You should be able to just about finish those, and I'll be able to come around and help you if you have any questions.